Now let's take an example and calculate line voltage, phase voltage, line current and phase current in star delta and the powers. Suppose that we have a resistive load at first, and suppose it's equal to 1 ohm, and let's take as well the source voltage, the phase voltage will be 1 volt. So it means that the line voltage here will be square root of 3 times V, which is 1. So it means square root of 3 volts. V phase will be equal to this. The load voltage, phase voltage, is equal to the source phase voltage. So it means V phase is equal to 1 volt. Line current is equal to phase current. So we can calculate now. We can calculate the current. E phase. This is V phase over R. And V phase, we said it's 1 volt over 1 ohm, it's 1 amp. From this we can calculate the power in one phase. This is V phase times I phase, and it's 1 times 1, it's 1 volt amps. Because we have 3 phases, so it means we can use this formula. So it's 3 volt ampere. Now if we have to calculate we can use this formula as well, VL, IL. It means that square root of 3, VL is square root of 3, IL is 1 amp. It means we have 3 volt amps. We can calculate P, square root of VL, IL, cosine 3, because we took a resistive load, it means it's 1. So it means it's 3 watts. Q will be 0. Now if we calculate here the phase voltage, the source phase voltage is 1 volt. So it means that VL is square root of 3 volts, and V phase here is equal to VL, and it's equal to square root of 3 volts. So it means we can calculate the phase current. This is phase current is V phase over R, or VL over R, and it's square root of 3 volts over 1 is square root of 3 amps. Knowing in triangle, in delta, the line current is square root of 3 the phase current. So it means it's square root of 3 times square root of 3, it's 3 amps, which demonstrates, show us that I delta is 3 times I for the same load. And now we can calculate SL is square root of 3, VL, IL, square root of 3, VL is square root of 3, and IL is 3, so it means we have 9 volt amps. So it means that S delta is 3 times S star connection. PL we can calculate is 3 square root of 3 VL times IL, it's 9 watts, and we can see that P delta is 3 times P star connection. Now if we take a reactive load now, suppose we take reactive load, for example, let's take reactive load, for example, let's take Z equal to 0.8 plus J 0.6 ohms, which is equal to 1 ohm, and argument 13 degrees. So we can calculate the phase. Remember that VL is square, we take V here 1 volt, so it means that VL here is square root of 3 times 1 square root of 3 volts. V phase will be equal to V, will be 1 volt. We can calculate E phase. E phase is V phase over Z, and it's 1 volt over 1 minus 53.13 degrees, so it means it's 1 amp. 1 amp, and argument minus 53, it's inductive. So we know that the line current is equal to phase current. We know that V line is equal to square root of V phase. So it means that here we have 1 amp, and here we have square root of 3 volts. So we can calculate SL, total power, square root of 3 VL IL, and it's square root of 3 times VL is equal to square root of 3 times IL, which is equal to 1, and it's equal to 3 volt amps. P star connection is equal to square root of 3 VL IL cosine phi, and it's S times 0.8. It means we have here 3 times, it's 2.4 watts. Q, we can calculate it, it's 3 times VL IL sine phi, and it's 3 times 0.6, and it's 1.18 volt ampere reactive. So now we go to the delta connection. We know that VL, V is equal to 1 volt. Here we have square root of 3 volts. V phase is equal to square root of 3 volts as well. We can calculate the phase current. Phase current is phase voltage divided by Z, or line voltage divided by Z, and it's square root of 3 over 1 is square root of 3 amps. And the line current is square root of phase current. It means that square root of 3 times square root of 3 will give 3 amps. We see that here the current, delta current, is equal 3 times current for star connection. Let's calculate SL, say square root of 3 VL IL, square root of 3, square root of 3, and 3, it means it's 9 volt amps. It means that S delta connection is 3 times S in star connection for the same load. This load is the same here and here. And PL, we can calculate it, is square root of 3 VL IL cosine phi, which is 0.08. So it means 9 times 0.8. It's 7 point, it's 9 times 0.8 is 7.2 watts, and we see that P delta connection is 3 times P star connection. QL is square root of 3 VL IL sine phi, and it's 9 times 0.6, and it's 5.4 volt ampere reactive. And we can see that Q in delta connection, it's 3 times Q in star connection. This is very simple example, and we see all the relations between line voltages, phase voltages, line currents, and phase currents. And thank you for